Hi everyone, my name is Sipogazi Ashanti Akoza and I am a student for the Advanced Diploma in Civil Engineering at the University of South Africa. Today I want to take you through my presentation for my report for the water supply project to be implemented by the Tshipice local municipality. Under this project or this presentation, I'll be covering the introduction, the project brief, the proposed layout of the project, the methodology, the Epanet results, and I'll give my conclusion with regards to the project. In water infrastructure and resource management, there's what we call water distribution systems. And I have been appointed as an engineering technologist to make an analysis of a water supply project. Well, water distribution systems exist to satisfy the needs of industrial, residential, commercial, and firefighting consumers. At all times, node to node, the system should be able to meet the needs and stresses of the consumers. Hydraulic analysis of the water distribution system is a key first stage in water supply and distribution system design because it reveals the flow, the pressure, the head loss, the velocity, the efficiency, and operation point of each pump. Well, this project seeks to supply water to 4 townships. As you can see, we have 4 townships. This is township number 1, township number 2, this is township 3 and 4. And also here we have the source, which is the Nyangwe River. And this is the layout of the whole township. We still have the source, which is Nyangwe River. We have our water treatment plant here. We have our bulk storage, and then we have all the demand centers. The demand centers are our townships, and here on this proposed layout we are given the length of the pipes. Like this one is 1,100 meters, this one is 950 meters. We are also given the reduced levels of those particular nodes. Well, right now I will take you through the methodology. For this project, we have used a program that is called Epanet. Epanet is a computer program that tracks the flow of water in each pipe, the pressure at each node, and the height of water in each tank. It also contains a state-of-the-art hydraulic analysis engine, and the nodes on Epanet monitor the water levels in tanks, flow rates, chemical species, and other variables over a period that spans several days. In the simulation, water aging and source tracing can be modeled. It is possible to update the network input data and perform hydraulic simulation using Epanet under Windows. The simulation results can be shown in several formats. It can come in the form of data table, it can come in the form of time series graph, counter plots, and color-coded networks. All fall under this category for visualization. Well, this is my Epanet results. As we can see here, it says run was successful. I'll just take you through on how I achieved this. Well, as shown on the previous slide, that the run was successful of the water network. From the given layout of the water network, I was given a source which was going a Nyangwe River, and then I've put it as a reservoir since it's a source, and also the water treatment plant, I've put it as a reservoir since it's another source. And then we have a bulk storage reservoir. Since it's a storage, then I've put it in as a tank. I have my demand supplies here, demand center number 1, 2, 3, 4, which I've put in. Okay, there's something that I did also. I came here and changed my patterns and renamed them SDP1. The patterns were given. These values, the multiplier were given from the question, so I've just input them here. And then also with regards to the curve, I was given a flow of 600 and a head of 80, and I've named it as my curve ID is PC1. And then also I've changed the elevation here to 74. I've used my reduced levels to get the elevation here. I need to subtract the reduced level of the bulk storage water from the Nyangwe River reduced level. Also with the pipes, I've put in the length, and then I have assumed or determined my own diameters for the pipes in order for me to obtain a successful run of the water network. With regards to the water demand centers, I've put in my base demands also as given from the question. For demand center number 3 was 85. For demand center number 4 it was 145. Demand center number 2 it was 75. And then demand center number 1 it was 70. And then I had put it in here to achieve my successful run. See, it's still successful, but also before I obtained this, I came across errors where I had to increase my diameter, and I also had to change the coefficient of roughness, because some of my velocities were actually more than 1.5, which is the maximum which is required. And also somehow I was obtaining a negative pressure, so I played around with the numbers or the diameters of the pipes until I was able to obtain a successful run. Like here, this pipe is 1050. Here, this one is 600 millimeters in diameter. So this is how I basically obtained my successful run of the water supply project. Well, in conclusion, I have ran the water system for an extended period of 72 hours. This was done to guarantee a clear analysis of the water system, and positive results were obtained. Therefore, the report shows that the pipeline reservoirs and pumps used can deliver the required demands to each township. I thank you.